Okay, 6-7, day 2. Yesterday we did the derivative of an e to a variable exponent function. Today we're doing antiderivative. So we're doing the antiderivative of e to the u du. And remember, antiderivative just asks what function has this as its derivative. Well, we know it's itself, as long as the derivative of the u is attached over here. So you have to have the u prime next to the dx, the du, whatever you want to call it, in order to integrate it back to itself. So on your sheet, another integration rule, the integral of e to the u du, you have to remember to have the derivative of the u attached to the du in order to integrate it right back to itself. Because remember, if you take the derivative of this, it is itself times by the derivative of the u. Okay, practice. Okay, we'll start easy. The integral of e to the 2x dx. I know the integral will be e to the 2x as long as I have the derivative of the u, and the u is right here, attached here. The derivative of this is 2, so that means I need to hit it with a 1. So I need a 2 here, which means I need a 1/2 here. So the 1/2 will carry. E to the 2x, never change the u, plus c. Number 2. Integral of the quantity e to the 3x minus 2 to the 4th e to the 3x dx. Okay, looks like we're trying to do a power rule here, but in order to do a power rule, I need to have the derivative of the inside attached to the dx. It's all right here. You always need the derivative of the u attached to the dx. I should probably put a little u prime here so you're used to seeing it. Oh, I got it under here. Okay, so the inside, and this one's pretty easy to see, but I'll write it out. The inside is e to the 3x minus 2. So the du, or the u prime, is here is itself times by 3, and then that goes to 0. So I need a 3 and an e to the 3x attached to the dx. Well, here's the e to the 3x. I'm going to slide it over. What I'm missing is the 3. So I can times by 3 here, as long as I multiply by 1/3 out here. So this is going away, and I just do my power rule now. So I'll get 1/3 e to the 3x minus 2 to the 5th times 1/5 plus c. That's just going to change that to 1/15. Number 3. Integral of e to the sine x times cosine x dx. Okay, this is just an e to the u one. So my u is the sine x. Derivative of sine is cosine x. Needs to be attached to the dx. I'm going to throw dx here too. So I've got the cosine. I'm going to slide that over and attach it. And now I've got my e to the u prime. So it integrates right back to itself, plus c. That gets thrown away with the dx. Quantity e to the x plus 1 squared dx. Looks like a power rule where I have an inside to a power. I can add 1, multiply by the reciprocal if I have the derivative of the inside attached here. Well, the inside is e to the x plus 1. The derivative is e to the x dx. There is not an e to the x here that I can slide next to the dx. I'm not allowed to introduce new x's to the problem. That changes the original function. Okay, it's not a power. I cannot integrate this with a power rule. But what I know is a binomial squared expands with Pascal's triangle, then I can do each term separately. So yes, we can still do the antiderivative. Okay, squaring, I could do FOIL, or I can just use Pascal's triangle with the 1 to 1 multipliers. So it'll be e to the x squared, e to the x to the first, and then e to the x to the 0, and then it's the 1 squared, 1 to the first. Throw some pluses in here. So simplifying here, a power raised to a power, I multiply. So I have e to the 2x plus 2e to the x plus 1 dx. Okay, I have to integrate each term separately. This is the one that takes a little extra work because it has a derivative up here that's not 1. The derivative on just this term is a 2. So I am going to write all three separately. And if you can do these in your head without rewriting, that's just fine. Just do all three separate. So this one, before I can integrate it to itself, I need the derivative of the u, which is a 2. So times by 2 times by a half. And it's just on this one term. That's why I took the time to write it separately. It's not on this or this, so I could not just put the 1/2 out here, because that would mean it's being distributed, and that's not true. So I get 1/2 e to the 2x. Here, the derivative of the x is a 1. I don't have to change anything. This 2 is going to carry along. And then the antiderivative of 1 is x with a plus c. Exponents are different here. These don't combine. That's it. So there was a little trick there into integrating, knowing that we could expand it, not just, oh, I don't know what to do. Let's see, that was 4. We're on 5. The integral from 3 to 4, so we're actually going to grab a calculator, of e to the 3 natural log of x dx. Okay, looks like an e to the u. The u is this 3 natural log of x. So the du, or the u prime, equals 3 times derivative of natural log of x is 1 over x. Okay, the 3 is not a problem. I can put a 3 in a 1/3. The problem is I don't have a 1 over x. I cannot introduce a new x term. So I can't do that. I need something else. Well, okay, let's go back in your bag of tricks. I see an e with the natural log, but there's a 3 in the way. I am allowed to bring this back up as an exponent. E to the natural log of x cubed dx. Oh, now things are looking better. We had that property yesterday. If I have an e raised to a natural log, those cancel each other out, and you're just left with this part of the natural log. So I'm actually just taking the antiderivative of x cubed. And now that's a simple power rule, where I add 1 to the exponent, multiply by the reciprocal, and plug in my values. So it's 1/4 times 4 raised to the 4th minus 1/4 times 4 cubed. And I don't have the answer written down, and I don't have a calculator handy, but I'm going to assume you can plug and chug with the best of them here. I guess I'm going to go on to the last one. The integral from 2 to 3 of e to the 5x. Okay, nothing tricky in this one like the last two, other than we're going to put the values in. Okay, integrating this, an e to the u. I need the derivative of this which is a 5. I need that here, which tells me 1. So antiderivative will be 1/5 of itself, evaluated from 2 to 3. E to the 5 times 3 is 15, minus 1/5. E to the 5 times 2 is 10. And again, I don't have a calculator here, so you'll have to finish that out. That's it. So we're going to pick up a few of the derivatives from yesterday and some antiderivatives today and a couple story problems that are not challenging. They're more like Algebra 1 than Calculus. So homework is from page 282, or not from, but on 282. We're going 16 to 40, multiples of 4. These are the derivatives. 41 to 59 odd. Then go back and pick up 52, 54, and 60. That was a bad 0. Okay, there we go.